So, good morning, one and all present here. So, today we are discuss about advanced foundry technology. My name is Dr. N. St. Rangarajulu, Assistant Professor, MIT Campus, Anna University, Chennai 44. Already I was worked there for 2 years in Baghdad University, Ethiopia. So, that is for course for this MSc Mechanical Engineering. One of the course is Advanced Foundry Technology. So that time I have prepared for this PPT for their curriculum. So this is very useful for foundry and welding technology. Today we are discuss about the foundry technology. So what is the foundry technology? What is foundry technology? Foundry technology is nothing but we can able to make a casting process in this foundry shop. There are so many methods in casting methods, and this very ancient period, they can able to do our forefathers, they can able to make a casting for copper frogs and other weapons and all those things with the help of a casting process. This is the very oldest process. Nowadays also in front of the Bharat building, they can able to Bharat Parliament building. They in front of that one, they will have a 23 feet height of the Natarajar statue. They can able to install in this one of the casting method, and also it is having a very big world big statue, and this is 1810 weight of metal. They are able to using this casting process, and also very aesthetic look and very good appearance for this Nataraja statue with the help of our near Kovilpatti. They are having one of the Stabadi, they will make this Nataraja statue for 18 feet height of foot to head of the Nataraja statue, and then base also they will have some 6 feet height. So this is gigantically they can able to present, and Abdul Kalam also present one of the Nataraja statue at 11 feet height for some of the atomic research center for foreign country. And also they are able to making so many, that especially for Tamil Nadu, they are making a casting process is they are making so many statues and toys and other things, weapons and all those things with the help of casting method. So that's why this foundry technology is very important one. Not only that foundry technology making the statues and other things, all the engine components, automobile components, two-wheeler rim wheels and car rims and other things, they are able to make a casting process only. So that's why we are able to go through this course is very important, play a vital role in engineering industry. So what is our objective? Give a good perspective with adequate depth of understand casting metallurgy and design, special casting processes, and including recent advances in casting. Course outline: patterns and pattern making, molding, casting metallurgy and design, casting process and special casting processes, melting, pouring and testing, recent advances in casting process. So these are all the course outline. So first one is pattern and pattern making. So introduction to foundry casting, foundry and casting. A foundry is a factory equipped for making molds, melting and handling metal in the molten form, performing the casting process and cleaning the finished casting. Casting is a process in which metal is injected into a cavity and allowed to solidify to the shape of the cavity. And the introduction to foundry and casting. So casting operation is not as simple as melt the metal, pour into a mold and let it solidify. The cavity is contained in a mold or die. Molds are generally made from green sand, that is a sand, clay and water content, plaster, ceramic, sand with resin binder, tool steel, metal, and they will have an introduction about this foundry and technology. They will have this one is open mold cast metal. This is a flask. This is the mold and runner. This one is a runner. This is a down sprue and a pouring basin, razor, casting metal in cavity, and they will have a core. Cope is the top of the box. Drag is the bottom of the box. In between these two, they will have a parting line is there. Next, we'll discuss about steps involved in casting process. So there are, first we can able to select the selection process selection, design and specification, determination of casting techniques. First one is molding material preparation, pattern making, furnace charge preparation, and then they will be able to make a molding and core making, then melting, metal melting, and making a casting. After the casting is finished, they will have a fettling. Fettling is one of the cleaning process, heat treatment and finishing, inspection and testing, finishing the product. So these are all the flow diagram of casting production. Advances of casting process. Casting can be used to create complex part geometries, including both external and internal shapes. Some casting processes are capable of producing parts to net shape. No further manufacturing operations are required to achieve the required geometry and dimensions of the part. Casting can be used to produce very large parts. The casting processes can be performed on any metal that can be heated to the liquid state. Some casting methods are quite suited for mass production. Casting offer cost and performance advantages because of their casting. Casting can be produced parts from metals that are hard to machine or form. And they will have a ferrous, non-ferrous, and non-metallic materials also we can able to make a casting process. Next, disadvantages of casting process. Limitation on mechanical properties, low strength and non-uniform properties, porosity, poor dimensional accuracy, and surface finish for some casting processes. Safety hazards to human when processing hot molten metals and environmental problems. Applications of casting. There is hardly any machine or equipment which does not have one or more cast components. For example, automobile engine blocks, cylinder blocks of automobile and airplane engines, pistons and piston rings, machine tool beds, frames, internal combustion engines and compressors, mill rolls, wheels, and housing of steam and hydraulic turbines, turbine vans, and aircraft jet engine blades, water supply and sewer pipe, stationary fittings and agricultural parts, etc. Pattern. A pattern may be defined as a mold or replica of the object to be cast, except for various allowances and core prints. A pattern exactly resembles the casting to be made. Patterns may be into 2 or 3 pieces, whereas casting are in a single piece. The quality of the casting and the final product will be affected to a great extent by the planning pattern. Functions of pattern. Properly manufactured pattern having a good surface finish reduces casting defects. Properly constructed patterns reduce the overall cost of the casting. Pattern making. A mold cavity to be used as a casting. Races, runners, and gates may form a part of the pattern. Pattern may contain core prints for placing the cores in a proper position. Pattern helps in establishing a parting line between the cope and drag part of the mold. Pattern helps in positioning the core at its proper position. So different materials used for making patterns are wood, metals like cast iron, brass, aluminum and its alloys, plastics, plaster and wax, All these materials have their own advantages and disadvantages. So first we will discuss about the wood. Wood is the most commonly used material for making patterns. Some its advantages are readily available and cheap, easily shaped and machined, joined easily by gluing, screwing, and nails, and intricate shapes can be made easily. Good surface finish can be obtained and preserved for a long time by applying protective coating on its surface. Some of its disadvantages are absorb moisture readily and its shape is deformed when it is drying or absorbing moisture. Its wear is high due to abrasive action of sand. Needs preservation for storing. Needs dry place for storing. Cannot be used for large number of casting impressions and its life is short. Commonly used to wood for making patterns: teak, deodar, walnut, pine, and mahogany. Metal also used for pattern making. Metals used as a pattern making material when a large number of casting impressions are to be taken into conditions are not suitable for wooden patterns. Some of its advantages over a wooden patterns are does not warp or storage, does not change its shape when subjected to moist conditions, or is in the content withstand, gives good surface finish and suitable for accurate dimensioning, and has good durability and strength. Next, they will have disadvantages of metallic or the followings. For giving different shapes, metals require a lot of machining for accuracy. It adds to the initial cost of the machine, space, and cost of patents. Metals are costlier than wood and are thus unsuitable for production of small number of castings. Some of metals get rusted due to atmospheric oxygen and moisture. Metal patterns are comparatively heavy and difficult to handle. Plastics, a variety of plastics are used for pattern making. Some their advantages are as follows: light in weight, show low shrinkage, durable, corrosion resistant, and good strength, good surface finish, and have better impact strength than wood. Disadvantages: cannot withstand severe shocks and require metal reinforcement in thin sections as plastic patterns are fragile. So plaster also used for pattern material. Plaster of Paris, pop, or gypsum cement are the constituent used for pattern material. Its advantages are as follows: suitable for casting of intricate shapes, process high compressive strength, easily worked by using woodworking tools, and no shrinkage allowance is needed for patterns as it expands during solidification. Disadvantages: cannot be used for mass production of casting and has low strength. So wax patterns are used like other patterns but are removed by heating and investing the mold. It is mainly used in investment casting. Advantages: possesses a good surface finish and shows good dimensioning. Disadvantages: since wax patterns are removed by heating, hence the pattern can only be used once. Pattern allowances. The following pattern allowances are provided due to which pattern is larger in size as compared to the final casting: shrinkage allowance, machining or finishing allowance, draft or taper allowance, camber or distortion allowance, shake or wrapping allowance, mold wall movement allowance. And the next, first one is the shrinkage allowance. All metals shrink or contract volumetrically during cooling from pouring temperature to room temperature in different phases. Shrinkages depends upon the following factors: pouring temperature of the molten metal, design and dimension of the casting, molding material, method of molding, characteristics of metals and casting. So shrinkage allowances for gray cast iron 7 to 10 mm, white cast iron 18 to 22 mm, malleable cast iron 10 to 11 mm, steel 20 to 21 mm, aluminum 16 to 18 mm, aluminum alloys 13 to 16 mm, brass 15 mm, bronze 12 to 20 mm, copper 16 mm, zinc 24 mm, silver 10 mm, non-shrinking die steel 0.8 mm. Like that, they will have a shrinkage allowance we can able to calculate. Based on the material usage, we can provide this shrinkage allowance. And next, we will discuss about machining or finishing allowance. Gray cast iron 3 to 10 mm, white cast iron 3 to 8 mm, medium steel casting 4 to 6 mm, large steel casting 6 to 16 mm, brass 1.25 to 6 mm, aluminum 2 to 6.5 mm, brass 2.5 to 7.5 mm, alloy of tin 2 to 5 mm. Draft or taper allowance, all vertical surfaces of patterns are provided with a slight taper for easy withdrawal of pattern from the molded and sand after molding. It is provided on both internal surfaces 40 to 67 mm per meter as well as external surface 10 to 25 mm per meter and is expressed either in degrees or linear measures. So this is the draft or taper allowances. This is a poor performance of the casting. This is a good performance in the casting. We are providing a taper on this taper allowance with the pattern with the taper allowances, without taper allowances. And distortion allowances. Distortion or warping of casting during cooling takes place due to uneven shrinkage of different parts of casting, poor design of casting, irregular shape of casting, unequal thickness of different arms, different rates of coolings. And next we will discuss about distortion allowance. Distortion allowance required for shape of casting, distorting the casting and the cambered pattern like this. We can able to do it. Then you can able to get the required shape of the casting. Distortion casting is one of the casting allowance. Next, they will have a shake or wrapping allowance. After molding, a pattern is shaken or wrapped by sticking the same with wooden piece from side to side. In this way, the pattern is loosened a little in the mold cavity and can be removed easily. It enlarges the mold cavity a little. A contract, this increase in size, negative pattern allowances provided in this pattern. Shake or wrapping allowance is the negative allowance. All remaining other all positive allowance. Mold wall movement allowance. When molten metal is poured in the mold cavity, movement of mold walls takes place due to excessive heat and static pressure exerted on the surface. It affects the size of casting. To compensate this, wall movement allowance are provided in the patterns. Wall movement allowances can be controlled by controlling the pouring temperatures and controlling the composition of the molten metal and the strength of the molding sand. Next, types of patterns. Types of patterns to be used for particular casting depends upon the many factors like quantity of casting to be produced and the size of the casting and the complexity of its shape and the method of molding. The generally types of patterns are solid pattern, split pattern, match plate pattern, hope and drag pattern, gated pattern, skeleton pattern, follow boat pattern, sweep pattern, and loose piece pattern, so on. So there are types of patterns. Here they will have a solid pattern, split pattern, match plate pattern, and cope and drag pattern. These are all the diagrams to explain different types of patterns. Solid patterns, some geometry as casting, adjusted in size for shaking and machining. Although it is the easier pattern to fabricate, it is not the easiest to use in making the sand mold. Determining the location of the parting line between the two halves of the mold can be a problem, and incorporating the gating system and the sprue into the mold is left to the judgment and skill of the foundry worker. Consequently, solid patterns are generally limited to very low production quantities. So next, they will have a split pattern. They consist of two pieces dividing the part along a plane coinciding with the parting line of the mold. They are appropriate for complex part geometries and moderate production quantities. The parting line of the mold is predetermined by the two pattern halves rather than by operator judgment. match plate patterns, the two pieces of split pattern are attached to opposite sides of the wood or metal plate. Next, holes in the plate allow the top and bottom, cope and drag sections of the mold to be aligned accurately. Then only you will get the proper casting, or otherwise mismatch will be happened. Cope and drag patterns, they are similar to match plate pattern, except that the split pattern holes are attached to separate plates so that the cope and drag sections of the mold can be fabricated independently instead of using the same tooling for both. For higher production quantities, match plate patterns or cope and drag patterns are used. So, reading assignments for following types: gated pattern, skeleton pattern, follow board pattern, sweep pattern, and loose piece pattern. So different steps involved in pattern layout can be summarized as follow. Get the working drawing of the component for which the pattern is to be made. Make a thorough and careful study of the drawing of the part. Make two views of drawing of the part on a drawing sheet using pattern makers. Scale for the metal to be casted. Add machining allowances as per the requirement of the part. Provided different allowances like draft allowance, wrapping allowances as per the requirement of the component. Locate the location of the core prints. Make suitable position and drawing of cores with allowances and start the manufacturing of the component. So making thorough carefully study of the pattern layout and establish the location of a parting surface, a number of parts in which pattern is to be made. Fabricate different parts of pattern using different hand tools and pattern making machines. Join the different parts by glue. Inspect the pattern for alignment of different parts and accuracy. So provide suitable fillets in order to avoid sharp corners. Polish the surfaces with sandpaper and give 3 coatings of shellac or make it moisture and atmospheric attack resistant, and impart suitable colors to different position of the pattern. So patterns are coated with different colors and shades in order to identify core prints, loose pieces, etc. Identify quickly the main body of the pattern and different types of pattern to form the main body of the casting. Identify the surfaces to be machined or not. Indicate the type of metal to be cast. So the standard commonly adopted color codes are red on the cast surface to be machined, black on cast surface to be left unmachined, red strips and yellow base for loose pieces and seatings, yellow of core prints, no color on parting surface, yellow strip on black background on core prints for machine operating, black strips on yellow background for supports. So much care is needed while storing the patterns as they lose their shape, get rusted and warped on a long storing. The following precautions are needed while storing patterns. Patterns should be stored at a place where temperature and humidity can be controlled. Patterns should be well confined and numbered. So patterns should be stored on suitable racks. Bin card system helps in easy location tracing of patterns. Patterns can also be recorded on a store ledger. So enough for today's study. So thank you for your kind attention. Any queries, please ask. So already first statement I told, the Natarajar statue is manufactured. So after the Natarajar statue is manufacturing, so there are 1.8 ton of metal is melted and it will get 1.5 ton weight of the casted product. Okay, so like that's why the metal is melted and it will take a 7-month duration for making that statue. So 3 months they are making for wax pattern. After that, they will take 4 months for casting the final product in that material. That material is 8 Astra materials. 8 materials are used for this casting for making a big Natarajar statue. Thank you very much for your kind attention. You can support me for this video, and we will discuss forthcoming classes for further video lectures very soon. Thank you very much. Okay.